Hi everyone, so today's lesson is going to be on highest common factor and lowest common multiple problem solving. The last few lessons we've been working a bit on Venn diagrams and product of primes. We're going to take a bit of a step back today, and what I'm going to do is I'm going to show you an alternative method that looks a bit like this table for finding the highest common factor and lowest common multiple. It's a lot easier than Venn diagrams, so if you really struggled with those, today's lesson will hopefully help give you an alternative, quick way of finding those. And we're going to be looking at some problem solving questions involving highest common factor, ones involving fruit and ones involving buses for lowest common multiple, and it'll give you a chance to start putting this into practice with real life examples, so it's quite exciting. The last thing you need to be aware of is there is an exit ticket in today's lesson, so it doesn't matter where you get to in this lesson, you may not finish everything. If you don't, all I ask is that you allow 5 minutes at the end of this hour that you're, or however long you're allocating, to have a go at that exit question and submit it to me online as before. Any issues or any questions, do message me on Show My Homework. Okay, so I need you to pick red, yellow or green to work on. This is a bit of a warm up. See what you can remember about finding highest common factor, lowest common multiple. Pause the video now if you're working from this video. Okay, mark your answers. The answer to green is on the next slide. Just pause the video if you're marking red or yellow. Okay, so on green, we've got Peter is completing an art project. He has 2 pieces of construction paper. The first piece is 44 centimetres wide and the second piece is 33 centimetres wide. This question is going to give you a taste of the types of questions we're going to be working on for the rest of the lesson. So he wants to cut the paper into strips that are equal in width and are as wide as possible. So this is talking about highest common factor. So we want to find the highest common factor of 44 and 33. That's essentially what this question is asking. It's just hidden in lots of words. Okay, so first of all, we're going to find factors of 44 and factors of 33. We might list those out in pairs. I've just written them out in a list here. We can see 11 is the number that's highest that appears in both lists. So we can conclude that 11 is the highest common factor and Peter should cut those bits of paper into strips of 11 centimetres. So using this example, there is an alternative method that I told you about to find the highest common factor and lowest common multiple. So we can actually put these numbers into a table. So we're going to draw a table with 44 and 33 as column headers. It's going to look maybe a bit like this. And then what we're going to do is we're going to look at 44 and 33 and we're going to pick any number at all that will divide into both 43 and 33. Now you might notice they're both in the 11 times table. 11 times table typically is 2 numbers repeating themselves when we've got 2 digits. So we're going to start by dividing both 44 and 33 by 11. Okay, and if we do that, we're going to write this in our row. 44 divided by 11 is 4. 33 divided by 11 is 3. Okay, so our numbers in there are 4 and 3. You can see those in purple. Now, if we look at those 2 numbers, the only factor 4 and 3 have in common now is 1. So we can't divide any further, which is why we've only got 1 row in this table. What that means is the highest common factor is going to be the number in the furthest left-hand column, so that 11. If we have more numbers, we'd multiply them together, but because we only have 1 number, we can conclude our highest common factor is 11. I'm going to show you another example on the next slide and you're going to have a go at this. Okay, so we want to find the highest common factor and lowest common multiple of 24 and 30. If you didn't attempt the green question, you've not watched the video, don't worry too much, I'm going to go through this from the beginning. So, instead of breaking our numbers down into product of primes and then putting them in a Venn diagram, finding out which numbers go where, etc., we're going to put these into a table. So I've got 24 and 30 as my column headers, and I've got a first column that's blank at the moment, and what's going to go in there are numbers that divide into 24 and 30, both. Okay, so it has to work for both and get a whole number out. Now 24 and 30 are both even numbers, which means they will both always divide by 2. So that's a quite useful fact. So I'm going to divide 24 by 2, that will give me 12, and I'm going to divide 30 by 2, and that's going to give me 15. Now for my next row, I'm looking at the two numbers I've just written in purple, 12 and 15, and I'm looking to see if they have any factors in common that are greater than 1. Now I can see that 12 and 15 are both in the 3 times table. So I'm going to divide 12 by 3. So I'm going to write 3 in my left-hand column. 12 divided by 3 is 4, and 15 divided by 3 is 5. Then I'm going to look at 4 and 5, and I'm going to see if I can spot any common factors that are bigger than 1. And the answer is I can't. So I know that I've completed my table as fully as I can. Okay, so to find the highest common factor, we are going to multiply together the numbers in the left-hand column. So 2 times 3 is going to be our highest common factor, and these don't have to be prime numbers. We just need to make sure that in our bottom row, those numbers in purple only have 1 as a factor in common. Okay, so highest common factor is 2 times 3, which is going to be 6. And if you wrote out your factor lists, you'd see that that is also the case. To find our lowest common multiple, we are multiplying together the area that I've circled in blue, so 2 times 3 times 4 times 5. So all of the left-hand column multiplied by the two numbers in the bottom row. So if we do that, 2 times 3 times 4 times 5 is 120. Our lowest common multiple is therefore 120. Okay, so just pause the video and make any notes that you need to. And what I would like you to do now is have a go at the your turn question on the right. So just pause the video and work through that. I've started the table for you. Okay, so hopefully you've had a go at that question on the right. We're going to start by looking for any number that divides into 45 and 60, and you get a whole number out. Now the numbers end in a 5 and a 0, so that means they are both in the 5 times table. So I'm going to start by dividing 5 into both of those. 45 divided by 5 is 9, 60 divided by 5 is 12, and then I'm going to look at 9 and 12. What number divides into both 9 and 12? I can see they're both in the 3 times table, so I'm going to divide them by 3. 9 divided by 3 is 3, 12 divided by 3 is 4. And then I'm going to look at 3 and 4. They have no factors in common other than 1, so my table is complete. Highest common factor is going to be this left-hand column multiplied together. 5 times 3 is 15. Lowest common multiple is going to be this L shape on the outside of your table, so the first column and bottom row, all multiplied together, and you'll get 180. Okay, so what I would like you to do is use the method we've just gone through to see if you can find the highest common factor and lowest common multiple of the following 5 questions. Please spend no more than 10 minutes on this. Pause the video now, as the next slide will go through the answers. Okay, so mark your answers, pause the video if you need to. I've written the answers in blue on the left and then some examples of what your tables might have looked like on the right. Your tables might have looked different if you'd chosen different numbers to divide into, but so long as you've got the right answers at the end, it should work regardless of which numbers you pick. Okay, so we're going to have a look at some worded questions, first of all with finding factors. So in this example, Lucy wants to divide 30 sweets in bags of equal amounts. And we want to know how many different ways Lucy can do this. So this question really is asking us to list all the factors of 30 and then count how many factors there are. So first of all, I'm going to list all the factors of 30. So if I do that, 1 times 30 is 30, 2 times 15 is 30, 3 times 10 is 30, and 5 times 6 is 30. I could write these out in a list. I'm not going to bother in this particular case because all I'm doing is counting the number of different factors. So the number of different factors are underlined in blue. So I've got 1, 2, 3, 4, 5, 6, 7, 8. Therefore, we can say that there are 8 different ways that Lucy can divide the bag of sweets into equal amounts, which does include 1. Okay, so what I would like you to do is have a go at this very similar question on the right. Please pause the video now so you've got some time to work through this. Okay, and you should have got this answer if you'd listed out all the factor pairs or factors. There are also 8 different ways. Okay, so this question is a little bit different. Marco has 21 apples and 49 pears. He wants to put them all in baskets, so each basket will have the same number of apples and pears. We want to know what the largest number of baskets he can make and still use up all his fruit are. Okay, so there's some key phrases here to help you understand what the question wants. Same number of apples and pears in each basket, and we've got the largest number of baskets he can make to still use up that fruit. So this question is about finding the highest common factor first of all, and then we need to do something else at the end. So what I'm going to do is use our alternative method to show the highest common factor. So I'm going to start by drawing my table. I've got 21 and 49 at the top. I'm going to look for a number that divides into both. I can see both are in my 7 times table, so the number I'm going to divide into both is 7. Now once I've done that, when I divide 7 into 21 I get 3, and 7 into 49 I get 7. If I look at 3 and 7 in blue, the only factor they have in common is 1, so I can't divide any further, and that means the highest common factor of the two numbers is 7. So by finding the highest common factor, we can think this through logically. If we had 7 baskets, that would mean we had 3 apples and 7 pears in each basket. Which works. We have the same number of fruit in each basket. Therefore, by finding the highest common factor, we have actually answered all of this question. Okay, so on the right-hand side, there is a very similar question. I would like you just to pause the video and have a go at this now. Okay, so hopefully you've had a go at that question. I'm going to put the answer up now. I'm going to use our alternative method involving a table again. Okay, so you can see in my table, actually each time I've divided 2 into the numbers above, I've got even numbers, and it's perfectly fine to have lots and lots of rows. All that means is when I find the highest common factor, I'm just multiplying all the numbers together in that left-hand column. And if we multiply all those numbers together, our highest common factor is going to be 16, which means this is the largest number of baskets that Claire can use and use up all of her fruit. Okay, so please have a go at these questions. If you're not feeling that confident with wordy questions, start on A through to H, but if you're feeling quite confident, I would go straight in and start on those problem-solving questions. Pause the video now before I go through the answers. Okay, so answers are as follows. Pause the video and mark your answers. Okay, so the next thing we need to go through is finding multiples. So if we had a question like this on the left, find the 7th multiple of 5, all that means is, so remember multiples are our times tables, we want to find out what 7 times 5 is. Okay, so 7 times 5 is 35, very straightforward. Okay, so on the right, just pause the video and have a go, find the 4th multiple of 9. Pause the video now. Okay, so hopefully you found that relatively straightforward. 4th multiple of 9 just means 4 times 9, and that is going to give us 36. Okay, another example of a question you might get. We've got a number that is a multiple of 9, but 2 less than a multiple of 10, and we want to know what that number is. Now, all I would do here is use my listing method for finding multiples. I would list out my 9 times table and my 10 times table together, and I'm going to look for a gap of 2 between my 10 times table and my 9 times table. Now, I might start by listing my times tables up to 5 times 9, 5 times 10, and I'll extend those lists if I need to. So what I'm looking for is a difference between my 10 times table and my 9 times table of 2. Now, if we look at these lists, we can see that that occurs here. So what we can say is the number that we're talking about is going to be 18, because that is the number that is 2 less than a multiple of 10. Okay, so just have a go at this question on the right, similar process, pause the video now. Okay, so I'm going to show you the answer now. We're going to start by listing our 8 times table and our 6 times table. We're going to compare the two lists to see which number is 2 more than a multiple of 6. So this time the numbers occur quite early in our list. 8 is 2 more than a multiple of 6. That's our answer. Okay, so now we're going to move on to a wordy question, finding the lowest common multiple. So we've got bus A and bus B, and they are at a bus station at 10 AM. Bus A arrives at the bus station at every 30 minutes, and bus B arrives at the station every 40 minutes. So we want to know when bus A and bus B will meet at the station again. Okay, so first of all, I'm going to underline my key timings, my key information. Okay, so the fact that they are at the bus station at 10 AM is important. Bus A is every 30 minutes and bus B is every 40 minutes. We want to know when they'll meet again at the station. So we're thinking lowest common multiple, and we're going to use our listing method again. But this time we're going to use our listing method starting from 10 AM. So I'm going to start with bus A, and I'm going to write out times that it's at the bus station, which will be every 30 minutes. I'm going to do the same for bus B. So bus B is going to arrive at the station every 40 minutes. Then we'll compare. Okay, so I'll just carry on those lists as long as I need to. You can see that I've added 12 in, and it's just gone over the line there. Please excuse that. So what we can see if we look at both of these lists is the next time those two times meet, those two buses are at the station again, is going to be at 12. And that means our answer is going to be at 12, okay? Right, so I would like you to have a go at this question on the right now. Very similar, slightly different timings, okay? So just pause the video and have a go at this question now. Okay, so possibly a little bit trickier. We're having to think about times and a clock. So remember, there are 60 minutes in an hour. You may have different strategies for adding up your minutes to get to that hour. So I'm going to just go through the answer now. Okay, so just pause the video if you need to have a look through those answers. Okay, so just pause the video now, have a go at these questions and work through in your own time. I'll go through the answers in just a moment. Okay, so the answers are up now. So for the final question, show that any multiple of 8 is also a multiple of 2 and 4. All you need to do is show your times table, so your 2 times table, your 4 times table and your 8 times table, and just show that every so often those 3 times tables intersect. So you could show with 2 or 3 examples. Okay, and some more questions here. So if you're feeling quite confident finding lowest common multiple, go straight ahead to the problem solving questions. Otherwise, start on A through to H, check your answers, and if you're feeling okay with that, then have a go at problem solving. Okay, and I'm just going to show the answers now. Just pause the video if you need to mark those. Okay, so this is the exit card. This is the bit you need to submit to me on Show My Homework or email your answer to me. So find the highest common factor and lowest common multiple of 105 and 225. You must show your workings in your answer, and you can choose which method you want to use. You can use the alternative method I've shown you today, or you can use the Venn diagram method and product of primes from last lesson.